Have you ever wondered why some winters feel incredibly harsh, with extreme cold spells dipping much further south than usual? It is a fascinating atmospheric phenomenon that connects the faraway Arctic to your local weather. The polar vortex becomes unstable primarily due to rapid warming in the Arctic region, a phenomenon often called Arctic amplification. This warming weakens the strong temperature contrast that normally keeps the vortex tightly contained around the North Pole. Normally, the polar vortex is a very strong, stable ring of frigid air circulating high above the Arctic, held in place by a powerful atmospheric current known as the jet stream. This jet stream acts like an invisible barrier, effectively separating the intensely cold Arctic air from the warmer air masses found in the mid-latitudes. However, as climate change leads to Arctic amplification, the Arctic is warming at a rate 2 to 3 times faster than the rest of the globe. This significant reduction in the temperature difference between the Arctic and the mid-latitudes directly impacts the jet stream, causing it to become weaker and more prone to dramatic meandering, similar to a slow, winding river. These exaggerated waves in the jet stream then allow warm air to push northward into the Arctic, while simultaneously permitting bitter cold polar air to descend much further south into areas like North America, Europe, and Asia. This is precisely when the polar vortex loses its grip and begins to destabilize, bringing those extreme cold conditions. Understanding this fundamental shift helps us interpret unusual winter weather patterns when they occur. When you hear reports of extreme cold outbreaks or unexpectedly mild winter spells in various regions, these events are often direct indicators of these dramatic alterations in the polar vortex and the associated jet stream configurations. It underscores that our global weather systems are profoundly interconnected, with changes in one region having cascading effects across the planet. Scientists are constantly studying additional factors, such as sudden stratospheric warming, which refers to abrupt temperature increases high in the stratosphere above the Arctic that can also contribute to weakening the polar vortex. These events send energy downwards, disrupting the vortex and sometimes causing it to split into multiple smaller lobes that can then drift southward, bringing intense cold. This complex interaction of atmospheric forces is a vital area of research, continually improving our ability to predict these dramatic and impactful weather events. Ultimately, the instability of the polar vortex is a clear signal of the profound changes occurring in our global climate system. By grasping how Arctic warming weakens the jet stream and allows cold air to escape, we gain a better understanding of the extreme winter weather phenomena that increasingly affect communities from the poles, highlighting the interconnectedness of our planet's climate.